Turing machine actually look like? What does it do? So here we are then. This is a Turing machine tape. It's divided up into lots and lots of notional cells. These are memory locations. Into these memory locations you can put patterns of bits that represent your program, patterns of bits that represent the data you're working on in the data part of memory, and you can have an infinite amount of it in principle. The only other thing you need to give this universal computing model is a read-write head. It visits a location on the tape, and you can either issue to it a read command or a write command. Now suppose these cells have been pre-initialized with zeros. If in the current head position you say read and tell me what it says it's a 0. You can then, if you want to, say I'm going to overwrite that with a 1. So in every cell of this memory there is the ability to erase and optionally to overwrite with something else. Now you can, if you're completely masochistic, and some Turing machine programs work out like this, you could always overwrite a 0 with a 0. There's nothing to stop you doing that. So it can shift left or right or not at all. And this is a binary Turing machine. There are other formulations which try to make life simpler and keep the tape shorter by saying, oh, I'll let you work in decimal arithmetic. What was discovered very early on was it really didn't matter how fancy your alphabet was for the tape. All Turing machines were the same. They all had the same computing power. It's just that sometimes you can keep the tape length shorter. Okay, so where does the program come from that causes this head to read and to write and to shift? In many Turing machine primers, you say, let's park the program code as tons of ones and zeros at this end of the tape and data in memory at the top end of the tape. And you'll read an instruction, it will tell you something to do with the read-write head, and you'll shift the head up into the data section, you'll do it, and you're oscillating back between reading program, writing data. The simplification I'm going to do, which is what Thibaut Rado does on his Busy Beaver Turing machine, and it makes life so much simpler, but I'm going to take the program code off from tape, sounds like good old-fashioned computing, onto cards. Not punch cards of the sort we've covered, but a Thibaut Rado card. Here's a typical Thibaut Rado type Turing machine card, and the idea is that every card represents an instruction in this Turing machine. So let us look at this card in the context of this Turing machine tape here. Thibaut says, for the sake of argument, let's assume that all these data memory cells are initialized to zeros. Since you don't know whether the head is going to shift to the right a lot or shift to the left a lot ahead of time, let's put it in the middle of this tape here. The 0 here means if you've got a 0 under the head at the moment, in other words you read and you see a 0, it then says here, the 1 is character to be written. So we have read a 0, it now says write a 1. Second binary digit here says now move the head. And again, what Rado did is not absolutely essential in Turing machine law. As he said, if I make the Turing machine work like this, it's a lot easier to show you what's going on. So please forgive me, in the Rado machine, the head must always move. You can't say, no, I'm stopping still here. You either move left or you move right. 0 equals left, 1 equals right. And then finally, what's this 2 here? That's your next instruction, 2. We're on card 1. Your next instruction will be on another card, card 2. So you've got all of these actions that must happen if you read a 0 in this current state of the machine. C1 is the start card. C0 is the halt card. Okay, so if something in one of these instructions says your next card is 0, you're going to halt. The 0 card is the halt card. So that's the general layout of these cards.
Well, now having seen this introduction, I'd encourage you to go on and watch the main Busy Beaver movie. And I think at the end of that, you'll get some real feeling for just what the word undecidability actually means.